Alright.
What do you know about magnets?
They stick together.
There's a North Pole and there's a South Pole, but you have to live in one.
Wait, so we're moving on past test material?
Yeah.
No, okay.
So we've already covered everything that's us.
Yeah. Did you want me to cover more?
Alice wants.
If you do the master set, says, you know, questions will come up and they'll go, oh, I forgot to do that, so. All right, so North Pole and South Pole. All right, what else do you know?
That one of them is blue and one of them is red, and they're consistently like that. But I forgot which one.
I think red is north, but I'm not 100% sure.
Yeah, I'm
Red's
not
positive.
sure. Yeah, and I know that, but it goes like this.
Okay, so if you take a magnet, North Pole and South Pole, the magnetic, there's something coming out of it called magnetic field lines, which come out the north into the south. And inside the magnet, it goes south to north, it's continuous. Anything else about magnets?
Similar to electrons, like attraction opposites repel.
But there's no electrons moving around with magnetism, right?
There are electrons moving around that magnets are created, or magnetic fields are created by moving charges.
I feel like you wrote that backwards.
Like attracts, oh, I did write that backwards. Opposites attract. Thank you for correcting that. Please note, this is not positive and negative, it is north and south. There are, we'll get to the other bits and pieces. What else do you know?
It can be induced by electricity.
More specifically, moving charge. Or leave that as a teaser for later on when we do the big reveal on that one.
The Earth has a magnetic field?
Pardon?
So the Earth has a magnetic field?
It does, and that brings up an interesting question. Where's the North Pole?
South.
Like what we would see as the South Pole?
Why?
Is it flipped at some point? Because it flipped at some point?
Well, it did, but I'm talking now, currently. If I take a magnet, if you're looking at a compass and you got the arrow there, the arrow points towards the north. It's supposed to, at least. In that arrow, the tip of the arrow, the part of the arrow that points towards the north is a North Pole. So if I have my Earth here, and I'm doing northern hemisphere centric, so this is the northern hemisphere and southern hemisphere, then a magnet will have a north and a south pole, and the north end of the magnet points north, which means this has to be a south end. So the Earth's magnetic field is running like this. This is a south end of a magnet. This is the north end of a magnet. What I have in green there is internal to the Earth, inside here. So when someone talks about the North Pole, even the North Magnetic Pole, it's really the South Magnetic Pole. They're talking about from a physics point of view, not from an everyday language point of view. It is really convenient that the North Pole and the South Pole mean the exact same thing, depending upon context. Now, at some point, it is expected to flip. There's definitely evidence, geologic evidence for it having flipped before. It's expected to flip sometime soon in geology terms.
That's what I heard.
Just means another 10,000 years.
It could be. I'm really curious, well, I'm not in a plane when it happens, but, and I don't even know how long it takes to do it. Is it just build up, build up, build up, and then boom? Or is it a slow progression over the course of, you know, like 100 years?
That
Would
would
you
be
end up with
interesting.
poles in the, like at the equator then or something?
Yeah, I always get the impression it's gonna be a very quick, but I don't know if that's quick in our lifetimes or
Right.
quick in geology terms.
Why would you not want to be on an airplane?
Don't airplanes use compasses? Or is that old school?
Well, yeah, but then what would happen?
I don't know. That's why I don't want to be on an airplane.
I don't know.
You know, if you're going, the north is this direction and the flip is very quick, then suddenly they're going, wait a second, are we going in the wrong direction?
But you just have to turn around like that, like, the plane's not gonna happen.
Well, then if you turn like, if let's say you're like 3/4 of your journey, and then it flips, so now we have to turn around.
Yeah.
You're gonna run out of fuel, and
Yeah.
then you're just gonna. Of course, I would hope the pilots have some common sense and would continue.
Well, Ferris is a pilot apparently.
And they also have, each airport has its own signal that it sends out, so I don't know if it needs the compass or just goes towards the signal.
For like a quick flip, wouldn't that like shift like gravity and stuff, and like make people like fly to the walls and stuff?
I would not think so. There's tenuous connection right now between any gravitational force and electric force. There are physicists trying to find that connection. I have even seen somebody who found some evidence of the connection, but considering I haven't seen anything in the past 20-some years from that talk I heard, I'm guessing it didn't go anywhere. I think I addressed your question.
Yeah.
Okay. All right. Now, in terms of South Pole, North Pole, and this is where it differs from electricity or electric charge, I can have a positive charge, I can have a negative charge. I don't have to have both, but I do have to have a North Pole and a South Pole. They go together. As such, if you think about Gauss's law of electricity, we have that the electric flux through a closed surface is equal to the enclosed charge over epsilon sub naught. But if you look at the magnetic flux, and the only difference between magnetic flux and electric flux is it's the symbol for the magnetic field instead of the electric field. Gauss's law of magnetism. We have B dot dA is equal to 0. Because whatever field lines I have going into my closed surface, I have going out. And so we end up with 0 there. Now, if a North Pole exists without a South Pole, in other words, a magnetic monopole, then that's all going to change. And there's some theorists who've already come out with a set of equations. I've seen the set of, if we happen to find a magnetic monopole, here are the equations. But we haven't found it yet. Although there are some physicists who are attempting to find it. Now, I do not know if the following story is true. I will say that as a grad student, I thought it was very funny. Now that I'm not a grad student anymore, it is not as funny. But the story was that some grad students decided to play a practical joke on their professor, and they were all working on the magnetic monopole. They faked data to make it look like they had found it. And then told them before they got too far. Again, funnier as a student.
But it's not possible to have a monopole, right?
Well, okay. Why are they looking for it if for every North Pole there's a South Pole? Well, there is, within theory, a possibility that it could have a North Pole here, and then connected to a South Pole somewhere else. So we still have the North Pole, South Pole, but from what we would look at, if we looked at that, we would just see a North Pole, we would not see the South Pole. And so that's what they're looking for.
But if, say, if you were to split it in half, if they were like two different.
That, and it doesn't, I mean, from a conceptual point of view, it's very difficult to conceive of what does just a North Pole look like. So, yeah, this is something that the gluttons for punishment, the masochists are trying to find.
It hasn't been disproven yet.
It has not been disproven, they just haven't found it yet. So if you do proof by exhaustion, yes, it has been proven not to exist. But pursuit of the $1 million prize.
If two magnets were like on opposite ends of like the universe, kind of like the electrons that you had mentioned previously, would they also attract? Like if they were opposite signs, like north and south?
Oh, if I had a North Pole and a South Pole like that, would they attract to each other?
Yeah.
I would think so.
Electrons.
But they could be far enough away that the South Pole is being affected by too many other things. Given enough time, if my universe consisted of only those, they would attract.
Is there always electric fields when there's a magnetic fields? Or vice versa?
It's possible that you could have a magnetic field without a noticeable electric field. That the electric field has basically been canceled out. If I have an electrically neutral thing, even distribution of charges, the electric field, for all practical purposes, would be close enough to zero.
But you have to have like electrons present for there to be a magnetic field and.
You have to have a moving charge. Now, in a typical magnet, like I go to Lowe's and then pick up some magnets, you have electrons basically zipping around nuclei. If enough electrons are all sort of zipping around in the same way, each one's creating a magnetic field. If they're all zipping around in the same way, then the magnetic fields will add like vectors, and you'll get a magnet. If it's just random, then any magnetic field that's produced is going to get canceled out by another one, except for statistical fluctuations.
Yeah, but it's not a separate thing, it has to involve moving charge. It's not like some force that exists by itself or something without the charge.
Not to my knowledge. It's for what we deal with mostly moving charge, but there is this other exception, which we'll talk about later.
Well, because we've never found like a graviton, right? So there's no particle involved with gravity that we know of yet. Like, so it's not that type of situation.
The charge or the particle that conveys the electromagnetic or electric and magnetic fields is the electromagnetic wave. It's a photon.
Okay.
So, and we have enough evidence of those.
So there are particles associated with.
Yes.
magnetic field.
Oh yeah.
Always.
The other one be like just earth metals, like iron magnets?
But, sorry, what's the question again?
Like instead of just the ore for moving charges, that can just be like rare earth metal magnets or like iron magnets?
I still missed the actual question. You're talking about the materials.
Yeah.
You're talking about what, natural magnets?
Yeah.
I mean, it's still because of something. If I pull something out of the ground and it's already a magnet, that's because it's been exposed to the Earth's magnetic field or some magnetic field source, which aligns the rotation of the electrons or the orbit of the electrons. Better wording. I don't know if I addressed your question or not.
I would say so, yeah.
Okay. Anyway, that alarm says I have class in 15 minutes. Let me hand some stuff back. All right, first this old stuff.